that's going to work, mostly. We don't really need the screen on for that, though. So, let me write this on. I think that would be easier for us since my pen not operational. Just to make sure, unless everything's backwards. I don't think it's really right. Okay, so for example 11, I can't see it because of the video up there. Somebody give me that function that it gives you for example 11. Where it
Squared plus 7x minus 5 over x minus 2.
Thank you. So, for this problem, I know this has a slant asymptote because the top has a degree that's 1 bigger than the bottom. So, if that's not the case, you don't even need to look for a slant asymptote. There's no point in it. There's not one there. But if the degree on the top is exactly 1 bigger than the bottom, then you have a slant asymptote. So, what you're going to do is you got to do long division of polynomials. So, you're going to have the top number goes on the inside. You got x squared plus 7x minus 5. And then you're going to put x minus 2 out here on the outside. And I believe that you guys do this a little bit in Math 3. But I know I did it a little bit in Math 3 too. It's usually not like one students do great with, so probably need a refresher. So when you divide, like if you think of dividing 248 divided by 3 or something like that, you're saying how many times does 3 go into 2? 9. How many times does 3 go into 24? That would be 8, right? 8 times 3 is 24. We subtract, we get 0, bring down our 8. How many times does 3 go into 8? That would be 2. 2 times 3 is 6. Subtract, and we got 2. At this point, we have to add a decimal. Or what we could do, actually I probably should do here instead. If I don't want to do a decimal for this, what I can do is this is my remainder. So I could take this number and put it over the over what we're dividing by our divisor, and I get 82 and 2/3. You could do decimal too, but this is more helpful for what we're doing here. So whenever you do this, you're dividing, multiplying, subtracting, bringing down, right? Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. This is something we rarely ever do anymore because we just use a calculator for it. But we need sort of the same steps to do it with polynomials, and the calculator can't do it with polynomials, so we have to do it by hand. So when you're dividing, this is a little trickier because it's pretty easy to say how many times does 3 go into 2 or how many times does 3 go into 24. What you're doing here is you're thinking, first of all, you really only want to think about the first term right here. The way I think of it is what times x would give me x squared. So what times x would give me x squared? X, right? I'm going to write it above this term because it's sort of like where I put this 8 above the 4 right here. It was going to go in my tens place right there. So your places are like x squared, x, and no x at all in this case. So I'm going to write it above this term. And then I need to multiply this by x minus 2. So I'm doing x times x minus 2, which means I'm going to have to distribute right here. So I will get x squared minus 2x. So I'll get x squared minus 2x right there. Everybody with me there? All right. Then you are going to subtract. Be careful when you're subtracting because sometimes the subtraction really looks more like addition. Because for this, you should subtract this and that should cancel out. That's the purpose of why you picked that number. But you are also subtracting this. And so when you subtract a negative number, it really looks more like you're just adding that there. So you would have 7x plus 2x, and you will get 9x. So we divided, we multiplied, we subtracted. What's the last thing before we start this all over again?
Bring it down.
Bring it down. So I'm going to bring this down. I've got negative 5 right here. And so I'm going to do the whole process over again. Now I'm thinking, what times x minus 2 would give me 9x? Really? Or what times x would give me 9x? Really? 9. Positive 9, right? So I'm going to put a plus 9 right here. And so I multiply, again, 9 times x is 9x. 9 times negative 2 is negative 18 right there. And then I am going to subtract. These will cancel, which is what should happen every time. I'm subtracting a negative 18 right here, which is really like I'm adding 18. So I'm going to get 13. Now, at this point, I cannot do it again because something times x cannot give me negative 13 without going like negative exponent sort of stuff. We're not going to do that. So this is our remainder. The way we can write this is we can put plus 13 over x minus 2. Okay? So what we have just done is we have rewritten this equation. F of x equals x squared plus 7x minus 5 over x minus 2 could be written as x plus 9 plus 13 over x minus 2. There. I'm going to switch to Desmos really quickly. I don't know if that'll show very good on the video since I'm doing this here. I'm getting ready to show you here. So if we go to Desmos and I type in f of x equals x plus 9 plus 13 over x minus 2, and just to show you, like, we'll call it g of x, but x squared, what did we have there? X squared, there we go. What was it? X squared plus
7x minus 5.
Plus 7x minus 5 over x minus 2. You can see these two are equivalent to each other. Here, let's see if I can drag that over to the side. There we go. So I realize on that video you can't see it very good, whoever's out today. But if I zoom out some, you can see this graph has sort of a line that goes through it right here. That line should be the part of your function that does not have the fraction anymore. So that x plus 9 is going to be our slant asymptote for this. And you can see, like, if it looks like those lines touch, but if I zoom in, they're not actually touching. So
But you don't want them to touch.
you don't, because in an asymptote it just gets closer and closer and closer, but doesn't touch. So your slant asymptote for that one is y equals x plus 9. Okay, so let's see, let's switch back. Cut that off there and right back here. So for this one, my slant asymptote is y equals x plus 9. It's just going to be whatever is not the fraction part there for the problem. Questions? Okay. All right, so everybody got it? So we'll fix it to erase so we can do our next one. All right. Somebody tell me what I got on that second one. looks really terrible because you've got so much going on. But with slant asymptotes, you shouldn't ever have to do long division more than like a couple times before you get to your remainder, because the degree of the top is only one bigger than the degree of the second, or of the bottom. So you shouldn't have to do it a bunch of times.
Are you looking at like the first number, or is it gonna be like the total minus?
Whatever is the highest. So it's not always the first. Sometimes I'll put them out of order. But whatever's the highest. You do not add them together. Yeah. So we're going to do long division. It's going to look really bad, but it's not nearly as, like, you should never have to do more than, like, 2 steps on this, because you should get a line, which is going to be y equals just 2 things right there. So on the inside of this, there is one thing you need to watch out for. I've got an x to the 4th, and then it skips to the x squared, right? So that makes your structure difficult to deal with whenever you are doing long division. Because, like, if we had a number, like if I had 1,062, I couldn't just leave that 0 out whenever I was dividing, because it's not a number, right? I'd have to include it. So whenever that x cubed is missing, it's sort of like you just left the 0 out. You need it for long division. So we're going to do this. We're going to call this 6x to the 4th plus 0x cubed minus 3x squared plus 2x minus 1. So if you are missing a term, whenever you have it in standard form in that descending order, put a 0, whatever variable you have there, so you can keep everything lined up. And then over here, we've got 2x to the 3rd plus 4x squared plus 3x. Alright, we are, again, asking ourselves, what number, or what times 2x cubed equals 6x to the 4th?
3x?
That's going to be 3x. I'm going to write it way over here above this 2x, because it's, you're kind of lining it up in its place. And since that only has x in the first power, I put it way over here. And so I am multiplying that by this whole thing. So 3x times 2x to the 3rd is going to give me 6x to the 4th. 3x times 4x squared, because it's got to get distributed, is going to give me plus 12x squared. There's the reason I needed to add an x squared term. If I didn't put that, it'd be all...
You mean the 3rd?
3rd, sorry. It doesn't need 3rd. Hold on. Yeah, I have a 3rd. If I didn't have that, it'd be all messed up. And then I've got 3x times 3x, which will give me plus 9x squared. And so we have divided, multiplied, now we need to subtract. So we're subtracting all of these. This one actually looks like subtraction a little bit more because they were all positive numbers. And this first term should cancel out, or if it didn't, you mess something up. So I'm going to get negative 12x cubed minus 6x squared, and then I'm going to bring down the plus 2x minus 1 there.
Since you're minusing 9x squared,
Oh, yeah, you're right. I messed that up.
Why do you write down the 1, 2?
Mostly because I know this is only going to have one more step, so you might as well have it there. You could wait till the next time to bring it down and be fine for that. You pretty much, like, you should only have to divide twice, because you should get a line, which means you're going to have like a term with an x and a constant term, and then everything else is going to be the remainder. So I just went ahead and brought everything down because of that. But if you wait until the end, it'll be okay. Then we've got to divide again. We're asking ourselves, what times 2x to the 3rd gives us negative 12x to the 3rd? Negative 6. So negative 6 times 2x to the third is going to give us negative 12x to the third. Negative 6 times positive 4x squared is going to give us negative 24x squared. And then negative 6 times positive 3x is going to give us negative 18x.
And then you make them all positive.
Okay, and when you subtract on this one, it basically makes them all positives because you are subtracting negatives for every one of them. It is going to cancel out this term, which is what is supposed to happen. And you will get a positive 12x squared plus 20x, and then minus 1 when you bring that down, or there. So you cannot do this again because you got an x squared here, and you got to multiply by x to the third. So you can't do it again. On these problems, you should only have to do it twice. You should only have to divide twice. So all of this stuff right here is your remainder. So you've got 12x squared plus 20x minus 1, and that is over 2x to the third plus 4x squared plus 3x. There. So this is your equation. But the question is really only asking you for your slant asymptote. So your slant asymptote here is y equals 3x minus 6. It's just that first part.
Do you draw out the 3 from there or no?
Hmm?
Do you draw out the 3 from there or no?
No. Oh, you could. You could do like a 3 times 2 minus x minus 2, but they probably won't do that.
Okay.
Okay, questions? Where are we at? Oh, gracious. Time's about it. All right, so your assignment tonight is